Hello all. Today we are going to start talking about matrices, which will be the focus of our week. If you haven't already, take this opportunity to print out the blank guided notes or set up the notes how you'd like. Remember that you can pause and rewind however you need. If you want to turn on subtitles, closed captioning is available. Here we've got our objective and our homework. We're still not going to worry about the presentation problem. If at some point we get to that, I'll let you know. So, we remember matrices. Some of this will feel very much like review for some of you. Some of you will be a little bit rustier, and that's just fine. So we're just going to talk about some of the main operations we can do with matrices, and I've given us some examples to work with. So the nice thing about matrices is that the rules are pretty similar to vectors, actually, meaning that the first three are going to feel pretty straightforward, and then the multiplication is where it gets weird. So if you think about these first three, we've got addition, and we have scalar multiplication, and then we have matrices multiplication. And like with vectors, the first three kind of just work out exactly the way you want. So if I'm going to take, for part A, if I'm going to say A plus B, well, matrix A is 2, negative 3, 0, 5, 7, 0.5 plus B, which is 1/2, negative 3, 0, 0, 1, negative 8. You'll notice that they have the same dimensions, meaning that they both have 3 rows and 2 columns. And so they add just the way you think that they should, meaning the ones in the same position are going to add together, and A plus B is going to be 2 plus 1/2. The next one is going to be negative 3, negative 3, negative 3 plus negative 3, so on, 0 plus 0, 5 plus 0, 7 plus 1, 0.5 plus negative 8. So with our final answer, I think I wrote it as a decimal in the answer here, 2.5, negative 6, 0, 5, 8, negative 7.5. So it works the way you kind of think it should. Now for B, it's saying, oh, A plus C. Well, you might think, oh, that feels like it's going to be just as easy as part A. But one thing I would hope that you notice is that A up here is what we call a 3 by 2 matrix, as is B. It's rows and then columns, versus C, which is 2 by 2. Now, these A and C have different dimensions, so if I want to add them together, I actually can't. And so B is no solution, because we have mismatched dimensions and we just can't add them. So it's a very easy problem if you notice those dimensions. On to C, we have 5B, and this is what we call scalar multiplication, if you remember from our lovely unit on vectors, which is just multiplying by a number instead of by another vector, or in this case by another matrix. So this is going to be 5 times the matrix B, and you can think of it as, again, it works kind of the way I hope it would make sense that it works. You can think about it as almost like distributing. It's going to distribute to every term in the scalar multiplication. And so then the next one is just every number is going to be, in this case, 5 times bigger, or whatever number, k times bigger. It works with negatives, it works with fractions. So then here we've got 5 over 2, negative 15, 0, 0, 5, and negative 40. So scalar multiplication, again, working pretty much the way you think it should. Now the last one, D, where we're multiplying 2 matrices together, is where it gets a little bit tricky. So first thing, let's write out our 2 matrices, in this case A and C. So unlike with adding, it's actually just fine that these dimensions don't perfectly line up. The important dimensions is that the number of columns in the first one has to match the number of rows in the second. So if you write out the dimensions for A, remember it's 3 by 2, and then C is 2 by 2. The important thing is that these two numbers have to be the same if we want to multiply them together. And so you can tell order really matters in matrix multiplication, because if we switch these two, that wouldn't work, because then we'd have a 2 and then a 3. So unlike a lot of types of multiplication, matrix multiplication is not commutative. So those two have to be the same, and for those of you who maybe remember this from previous, it's because we're going to take this row and basically do a dot product with it. Remember how I said this is kind of like vectors? Take this row and flip it to line up with this column, and as I say, quote unquote, do a dot product with it, and that's going to be our first term here. So this is going to be 2 times negative 2, which are the first terms, and then negative 3 times 4. And we're adding it, and that's going to be our first term. The next term, and we'll work through this in a second, there's only so much space I'm getting here. Working through this next one, we will take our next row, and again take our first column and dot product it again here as 0 times negative 2, so the first one here, the first one there, plus 5 times 4. And then our last entry is going to be here in this column, 7 times negative 2 plus 0.5 times 4. And that's going to be the first row of our new matrix. You'll notice, oh, we haven't used this column at all yet. That's all right, we're going to put it in here. I'm just going to simplify first to give ourselves a little room. So, pause here, we're just going to do some quick arithmetic over here to give us some more space. All right, for the second one, we're going to do the same thing again, starting right at the top, this row, and now the second column, similar thing. Take the first one, so then it's 2 times 2/3 plus negative 3 times 0. Next term will be this middle one in red, and then multiplying it out here. So 0 times 2/3 plus 5 times 0. And then lastly, the light blue multiplied here, 7 times 2/3 plus 0.5 times 0. And our last step will just be to do that arithmetic, and you'll end up with your multiplied matrix. All right, and there you have it. One thing you can also do, and that we'll talk about if you remember how to do it, one thing we'll talk about in our next lesson is this is absolutely something you can do on a graphing calculator. If you're feeling ready for that, absolutely go ahead. Otherwise, you'll see that in the next lesson. Some of you might be wondering, what in the world does this have to do with systems of equations? This has been bouncing around. Here's one example, and then you'll see a couple other examples about how these all tie together in the next lesson. So what we see here is we have two matrices and we have variables in them. These two being multiplied together, it says equal 6, 7 as a matrix. And while this looks a little bit different, this is just a straightforward system of equations where we've got variables in the matrix and we're going to solve. So you'll definitely see this in the homework of where there's variables and you're solving for them, just as a different way to test that knowledge. So what we can do here is that we just reviewed and how to multiply two matrices together, so we're going to do that here. Again, we're going to multiply the first column by here, and so then we end up with 2 times x plus 4 times y, and then here we've got second row times -1 times x plus 3 times y. And that's going to be our new matrix. We've multiplied everything together. So on this side, we end up with 2x plus 4y and -x plus 3y. Well, if we look on the other side, that's equal to 6, 7. And now we have a lovely system of equations that we can solve where the first terms are going to be equal to each other and the second terms are equal to each other. So while it didn't necessarily look like a system of equation problem at the outset, here we have a nice system that we can solve using elimination or substitution. I'm going to use elimination, multiply the second one by 2 to cancel out the x terms. And when we combine those together, we end up with 10y is equal to 20, y equals 2. And plugging that back in, we end up with x equals -1. So our final answer is here. So you're definitely going to see some of that in the homework as well. Ones where you already have all your numbers and you're working through, some where you're solving for variables. If you can do things on your calculator, great, but do make sure you can also do them by hand. So an example like this, you need to be able to know how to multiply them in an easier fashion, because you can't put variables into your calculator. Let me know if you have any questions, and I'll be available on Google Classroom and Zoom.